All right, Owls, this is Mr. O with the next set of flip notes. Actually, our final set before we track out here. This is going to be based on plate tectonics. We learn about plate tectonics after layers of the Earth because plate tectonics are affected by the structure of the Earth and what happens with that. And then when we get into plate tectonics, we're talking about the lithosphere, which is one of the layers that we addressed. All right. In your table of contents, we will do this in class. We're not going to worry about this slide, but please keep in mind these things when you're doing these flip notes. You can pause the video at any time. If you have questions, write them down. Please watch the entire video to the end. There will be information needed throughout it. And keep your notes neat. They will be what you will study from for majors and minors. And at the end of this, you should have your notes completed. Any questions written down. Let's get started. On your sheet that I gave you in class, we start off with 3 vocab words. The first one's tectonic plates. And if you did not know, these are huge slabs of rock that cover the entire surface of the Earth. And this next slide will show that there's a world map and then the different plates that cover the Earth. They all have names. They're basically named after the continents that are around for the most part, except for a few exceptions. But those are the tectonic plates. Also, plate boundaries. By definition, it's where 2 tectonic plates meet, meaning they come together like puzzle pieces. And where they meet is known as a plate boundary. A boundary line is a line where, even like where 2 states meet, but these are definite lines where these 2 slabs of rock would meet. And then you can see the different boundaries and where they meet and the different effects and which way they move and how they move, and we'll talk more about that in a little bit. So what causes plate movement? And that would be convection currents in the mantle. We talked about that with layers of the Earth. This is something you should be able to write down without even looking at these notes. And let's take a look at this picture. You can see that with a boundary where that ridge in the picture is, you can see that there's 2 different convection cells underneath it. And depending on which way those convection cells are moving, they can either go away from each other or towards each other or side by side. And that will affect the crust and the Earth in different ways, and we'll talk more about that as we go. There are 2 types of tectonic plates in this world. There is oceanic and there is continental. Now, there is far more oceanic than there is continental. Obviously, if it's 100% underneath the ocean, it's going to be an oceanic plate. If it's majority on a continent, it's going to be continental. That doesn't mean an oceanic plate can't run up on a continent, or the same with the continental, they can run into the ocean a little bit. But for the most part, they are where their name is where they are. There's 3 types of plate boundaries. In general, there's divergent, there's convergent. The confusing thing about convergent is there actually is 2 types of those, and there's transform boundaries. Now, if you Google this, you can realize there are different subsets of each of these boundaries, but in 6th grade, we got to keep them pretty general. So first thing we're going to do is with the plate movement, like I said, the convection cells underneath each of these boundaries will tell which way they go. And based on that, we need to know which way the arrows are. So divergent is each plate, each of those arrows represent a plate, and those plates will be going away from each other because they dive away. Convergent, they both come together, but in a convergent collision, they hit head on, and the second type is convergent subduction, and that one would slightly go underneath when it gets hit. We'll talk more about that as we get going. And transform, they're running side by side. They're not actually diving away or colliding. They're actually like sliding and scratching next to each other. And here's a picture of the different plates and how they would look in general, just so you can have an idea of how that works. You need to know what the plate boundaries will do to crust. Now, each of these boundaries do a different thing to crust, and with divergent, new crust is created because the plates will open up and magma from the Earth's mantle will fill in and cool off and make new crust. With convergent, old crust is destroyed, meaning crust is ruined, it's getting pushed into the mantle and is getting remelted and put back and recycled. And we'll talk about the rock cycle later on with that too. And with transform, crust isn't really created or destroyed with this boundary. You can say it gets broken up a little bit, but it's not pushing it back into the mantle, or the mantle's not opening up and adding new crust. So with transform, it's neither. So you can see each of these boundaries have a unique effect on the crust. Now onto the back of your notes, you need to know the landforms. This is where this unit gets a little tricky. You have to know landforms per boundary, and each boundary has different things that can happen. And here they are. I'm just going to let you write these down because in class we'll talk about these. There are more things that happen with these boundaries. For example, volcanoes are made at multiple boundaries. You can find a volcano at different convergent boundaries. You can even find a volcano at divergent boundaries in some unique cases. But these are the different landforms that are created. This is one of those things I'm not going to talk about in detail now because we will talk about that in class later. Now, looking at those two convergent boundaries, we have to be able to compare and contrast them. So if we're looking at this, with convergent collision, you need two continental plates. If there's not two continental plates, it can't be convergent collision. And it only creates mountains. That's the other difference for convergent collision. And then if you look at the convergent subduction side, you can have two scenarios. You can have a continental plate meet an oceanic plate, or an oceanic meet another oceanic plate. And the other difference would be what it creates, that the landforms created. But the things they have in common are they both are convergent boundaries, meaning both of these plates are coming at each other. And then the second thing is they both destroy old crust. So in this unit, you're going to have to be able to compare and contrast both of those. And the last section we're going to do here is based on earthquakes. Earthquakes produce seismic waves, and that word's important because the scientist who studies them is a seismologist. He uses a seismograph to measure seismic waves or seismic activity. And there's three different types of seismic waves when earthquakes occur. There are P waves, I know, haha, but the P stands for primary. There's S waves, which is secondary, and there's surface waves. And we'll talk more about earthquakes when we get into this. And last but not least, there is the rate of plate movement, which means that these plates are always moving all the time. You got to think convection currents are happening in the mantle all the time, which would make these plates move all the time. And you need to know that they move centimeters to an inch per year. Now, I understand I use two different systems there, meaning I use the metric and the standard measuring system. But based on the state of North Carolina, this is the fact they want me to teach you. But what it is they don't move a great deal, but they are moving every year. You might not think an inch is a lot, but an inch is a lot when it comes to moving plates across the entire world. All right. Remember, if you have any questions, please write them down, and we'll talk about them in class when we go over these.